Right. In this case here, we are given the points T, R, A, and B. Then we are given that even D there, which is perpendicular to TR. That's why it's 90 degrees, which means here it's also 90 degrees. We are already adding information to our diagram. Then here is angle alpha. This one is angle beta. This is perpendicular to this one. That's 90 degrees there. Therefore, which means this angle here, it becomes alpha plus beta. We are also given that this is perpendicular to that one. This is perpendicular to this one, which in a way would mean that even these two lines are parallel in that regard. And if this angle here is beta, it means there is this angle again is beta, because these are alternating angles. Coming to the top triangle here is also a right angle triangle. This angle is alpha. This is 90 degrees, which means this part becomes 90 minus alpha. As we continue, we would find that the question is saying prove that TR is given by that one. But let's just use our information so that we can be able to find TR. Can you see? We are looking for TR, yet we have the angle opposite TR, which means in this case, we are making use of the sine rule. That is to say here, TR over the angle that is opposite side TR is the whole of this angle, which is TR over sine of this angle, that is sine of alpha plus beta. In brackets like that, we are saying it's equals to, now we want to find the other side to use. So can you see in this triangle TR, we can also make use of the side AR. Why side AR? It's because side AR somehow we can be able to find it using the other part of the triangle there. Therefore, that is to say, my AR is equals to AR over sine of the angle opposite AR, which is 90 minus alpha, which now implies that my TR over sine of alpha plus beta is equals to AR over sine 90 minus alpha. Sine 90 minus alpha is equals to, in this case, not sine, but it's equals to cos of alpha. 90 minus alpha is equals to cos alpha, which in this case implies that TR is equals to AR multiply, I'm now cross multiplying there, AR over cos alpha multiplied by sine of alpha plus beta. Now, I'm now worried with finding AR, because on my where I'm going there, whether I must prove to, there's no AR. So I must get rid of the side AR. If you look at side AR, it's within this right angle triangle that is at the bottom there. Then to this angle, AR is a hypotenuse, it's opposite the 90 degrees, and I have an opposite side. So the ratio that make use of opposite and the hypotenuse, it's a sine. So for me to find the AR, I'm going to say sine of my angle there, which is angle beta, is equals to sine beta is equals to opposite over hypotenuse, and my opposite is h over my hypotenuse, which is AR. Therefore, which now implies there that AR is equals to h over sine of beta, which now implies in this case we are saying in place of AR, I now replace AR with H. Remember here, I'm saying TR is equal. I can also rewrite it as AR multiplied by sine of alpha plus beta all over cos of alpha. And in this case, I will replace my AR with H over sine beta, which now means it's now equals to AR, it will be H multiplied by sine of alpha plus beta all over sine beta multiplied by sine beta multiplied by cos alpha. So which means it's now actually implies that my TR is equals to, as I rearrange and write it in the way that I must prove it to, it will be now equals to H multiplied by sine of alpha plus beta, everything over cos alpha sine beta. Thank you so much. It has been proved. Bless you.